particularly testing of object-oriented systems. Okay, this first component of defect estimation complements what we talked about in the video, having to do with estimation of duration needed to finish some tasks. At a general level, I trust you folks will have watched the video. What was the recommendation given? Give me a couple recommendations for estimation that came out of that video or expressed there.
Don't be optimistic.
Okay, good. Good. We have a tendency as software developers to be unrealistic in our estimates of how long things will take, but typically, almost invariable in an optimistic direction. Moreover, we tend to be overly narrow in our views of the possible ranges of how long it would take. In other words, overly confident about the accuracy of our answers. We tend to lend too much credence to our estimates of how long things would take. Think they're much more accurate than they actually are. And this is a major problem because often stakeholders will benefit from knowing something about the uncertainties involved, but we often don't reflect this. So in order to arrive at a more or less risky estimate, what do we do? What's a key thing that we do? Well, first is you don't estimate a big chunk of work as a single chunk of work. Instead, you break it down into pieces. And the word for it here, if you go into firms downtown, they'll often talk about estimation by decomposition, meaning you're decomposing this big chunk of work into pieces, and you can better estimate those pieces. There's less guesswork. There's less wishful thinking that goes on when you're dealing with a small bit of work in terms of how long it would take compared to a large description. Often we pull wags out of the air, just wild guesses, to estimate how long an overall task will take. But if we break it down into pieces, we're forced to think concretely. And that makes a huge difference in terms of the accuracy of our estimates. We also give range estimates for them. We check the range estimates against observation. So we try to correct for our tendency to be overly optimistic. The tendency to be overly optimistic can turn what would be considered a successful project into what may be viewed as an unsuccessful project, unfairly, just because we advanced an estimate that was too optimistic early on. We set expectations such that we would almost invariably fail to deliver it. The stakeholder might have been perfectly happy with that same project if only we had given a more realistic, longer estimate and come in within that estimate, they would have been a happy camper. And it's not merely that their expectations are off. Sometimes stakeholders plan processes of their own, plan important transitions of their own around our estimates. It's not merely that they're hoping for something sooner and they're excited when we mention it and then they get disappointed. It's that they've sometimes been counting on it in terms of their plans. You think about an IT organization for a large company. Maybe it's a bank. Maybe it's a manufacturing firm. Maybe it's a software development company. You think about an IT unit for that organization, like many of you will go to in your internships. If they promise rollout of certain, say, new financial software on a certain date, there's a lot of planning that goes in by the stakeholders, by the folks who are the customers of that, the users of it. They need to plan around when to transition there, when the training will be, when they'll be bringing the data from the old system to the new system. All those sorts of things get planned. Even the folks maintaining the servers have to plan, okay, when a certain server will be freed up and a new one because it's transitioned over to this other one, so that older server can be repurposed. So the point is, when you make an estimate and the estimate's off in an optimistic direction, people can be bitterly disappointed, not just because they're let down, but because they have structured their lives, their plans around that, and now they're thrown into disarray. And they have to replan dynamically. So estimation, ladies and gentlemen, good estimation, grounded estimation, cross-checked estimation, continuously improved estimation is one of the keys to success in the software area. Overly optimistic estimates, estimates that are off, are one of the biggest causes of failed software projects. But there's another thing we can do about estimation to simplify estimation in a big sense. Something we can do to make our estimates less far off besides decomposing them and giving range estimates and checking our range estimates. We have the luxury in our processes of choosing a way of delivering software that's less prone to big misestimation. And what is that way? What is that way of arranging our processes so that they're less likely to be thrown off by bad estimates? We build software in a what way? It begins with an I, a big purple I. We deliver them in a way that is incremental. Thank you. There's an L at the end. Incremental. Right? We deliver software in an incremental fashion with short delivery cycles. Right? Many places in town might be 1 week between cycles. I think point 2 was doing 2 or 3 weeks between cycles, if memory serves me. It may have been Vendasta that was doing shorter cycles yet. This is standard stuff, ladies and gentlemen, because you're less likely to be fooled. Less likely to think in some abstract way, not concretely. If you're dealing with the next week or the next 2 weeks, you are thinking, oh, this day I have to be out. This day, we have this training going on. So-and-so is gone from the office for this time. We're planning a small bit of functionality that we're going to be fooled less by ourselves. We break it down, but we break it down into fewer pieces. And as a result, with incremental delivery, if we plan 1 week cycles or 2 week cycles, you're less likely to be wildly off in how far you can get. You think very concretely. And hence the reason why you're using 2 week or so cycles for this class, to prevent that delusion. So incremental delivery with a big purple I is very, very, very helpful for lowering the risk of being catastrophically off in a way that makes people count on things and be disappointed. Another is the process of what's called time boxing. Did you discuss this in 370? Time boxing? Okay. Time boxing. So the idea with time boxing, you talked about a rational unified process there? No? No. Did you talk about scrums or extreme programming or Crystal, any other sort of incremental, what are called agile processes? Was that a major topic at 370 for you?
He hated Agile, so we didn't teach any of it.
Okay, agility, you didn't talk about agile processes, no?
No, very anti-Agile.
Okay, that's interesting.
He basically said that Agile, the whole refactoring part never happens, so you just get increasingly unstable and just convoluted code as you go along.
So there is some truth to that. And what sometimes happens is, and something to which I would be open as an instructor in this class, is what teams deal with that in an agile way. What they declare is, one deliverable. Maybe it's ID 3. Maybe it's ID 4. Could even be ID 5. Consists of basically refactoring. You're basically refactoring the code. What do I mean by refactoring? Who could tell me? When I say refactoring, what do I mean?
Organizing it.
Okay, it's organizing. It's basically reworking the code to improve non-functional attributes like performance, quality, etc., without changing the functionality. It's often restructured in a way it's more transparent, it's more better documented, it's clearer, it's better expressed. You clean it up, in short, in a refactoring step, but the functionality remains unchanged. You're not adding features, you're not adding a new function to it, you're not changing its behavior. So with refactoring, ladies and gentlemen, it's a key step, but it's true, it can get ignored in agile processes, and what teams will often do is take a agile sprint. They'll make one of their sprints. Maybe it's ID4 in this class about agility, about refactoring. It'll be focused on refactoring. No new functionality. We're going to make more solid and clear the code for ID4. That would be a good thing with a capital A. So agile processes, ladies and gentlemen, are pretty much the standard in most areas of small and medium-sized firms. It gets a little bit dicier with big firms. Think about a firm like Microsoft that has this big beast of Microsoft Office to pull together. You've got software development teams working on Word and on Excel and on PowerPoint and OneNote, and all of them have to come together for a given release of Microsoft Office. And those releases occur, on many month boundaries. Maybe it's every year or two. There it's harder to roll things out to the stakeholders, to the users, on a small, short time frame. You've really got to coordinate so the things that are supported in Word are well supported in Excel too, and they can talk with each other. They have interoperability, so if you paste a Word table into Excel, it's a happy camper, etc. So, ladies and gentlemen, agility is pretty much the norm for small and medium-sized projects. It's the most typical type of process you will see, agile processes. And you will see it being practiced all around town. In fact, time was that you would see a fair number of consultants coming in to help them adopt better agility techniques at some of the local firms. So agile processes, like them or hate them, they tend to be the norm for a lot of shops. And its most distinguishing feature, one of its most distinguishing features, is incremental delivery. We may have a little bit more coverage of agility, and I may actually have a lecture which also talks about balancing it with sort of rigor in terms of software development, quality, processes, etc. But agility is a very important feature of today's software environments. Okay, so time boxing. What is time boxing? Time boxing consists of basically making a given deliverable of your software be viewed as complete if it comes within a certain time rather than with a certain set of features. So rather than taking as long as is needed to roll out certain features, what you do is you take as many features as you can put into a given sprint. So we'll say it's a 1 week sprint or 2 week sprint. You time box, you cut off like Procrustes' legs in ancient Greece. Or so went the myth. You cut off the extra features that will not fit within that 2 week cycle or 1 week cycle. You triage, in short, ladies and gentlemen. You triage. And stakeholders understand that. So they expect, as the invariant, to get software delivered in 2 weeks' time, rather than get delivered with these features by the next time they get a rollout. So time boxing is one way that projects are kept on schedule in an adaptive way for agile processes, and that we deal with estimation challenges. We fit things into a very defined schedule. And of course, from a continuous integration standpoint, we look at, from a continuous improvement standpoint, we look at what is it that's throwing off our estimates in terms of how many jelly beans it takes to implement a given feature within our agile processes. Jelly beans are often ways we estimate how much work is involved, and we'll improve our estimates going forward based on our learning from what we can fit into a given time box. Okay, so incremental delivery, one of the big ways we deal with estimation challenges. You break things up into small deliverables. Okay, those are some beginning comments. Comments related to the videos that you should have watched. Okay, so ladies and gentlemen, I would like to go and talk now about defect estimation. Okay, this complements that earlier discussion of estimation of time by talking about